Hello and welcome to another in the series of the IMarEST webinars on the radar. These series seek to highlight cutting-edge developments in the marine sector. Today's cutting-edge technology we're going to be talking about is digitalisation in subsea operations and marine assets. It's the second part. The first part was a few weeks back where a bulk of the presentations were made. The second part is about a panel discussion based on your questions, and we'll start with a short presentation from Kjell Eriksson. The panel is made up of 5 experts. These are Kai Langstrom, Principal Marine Consultant, Technical Advisor at Seaflow Consultancy, Kjell Eriksson, Vice President, Digital Partnering, DNVGL, Peter Topaksis, Project Manager, Fleet Sustainability, Fugro, John Butler, Director, Energy Transition and Sustainability and Transition Ignition Limited, and Mitch Johnson, Program Manager, Shipboard Technical Services, Ocean Engineering Projects Group. Without ado, I will pass you across to Kjell Eriksson to give us a short presentation, followed by the panel discussion. I would encourage you to put your questions into the Slido, and we look forward to hearing from you. Thank you very much. Kjell?
Yes, okay, thank you, Roland. Thanks for the introduction. Let me share my screen. Okay, there we are. I hope you all can see my screen saying making your digital twin a real asset. So what I will share with you today is the work that we have been doing together with the industry of finding a way of quality assuring digital twins or other digital assets. And hopefully this will serve as a good introduction to the panel discussions that we will be having later on. So end of last year, DNV published a recommended practice like we often do when we see a topic that would benefit from a form of standardization and a common approach on qualification and assurance of digital twins. This started with a dialogue with Technip FMC. Technip FMC were increasingly being asked by their clients, i.e. the operators, to provide digital replicas, digital twins of the hardware that they typically deliver. They felt they had good quality assurance processes in place for the hardware production and installation activities. They also felt that they had good software processes. But the digital twin being a blend of the two, i.e. a replica of the hardware, they felt that there was a missing link, which was a potential liability and exposure for the company in case the digital twin didn't perform as intended, but also a source of internal inefficiency. So was there a way of doing this in a smarter way? Throughout the development, we ran a series of workshops or pilots with Aker BP to get an operator perspective, with Kongsberg Digital to get a perspective of someone supplying digital twins, and NOV as a reputable vendor or supplier of advanced equipment. We also met with most international companies, a lot of national companies, industry organizations as well. And as with any DNV recommended practice or standards, we ran a hearing process. So we had just below 50 organizations taking part in that and commenting on the standard, and then published this at the end of October 2020. The input we got in this process is not the only input. Also, what we did last year, at a webinar, we had 500 participants globally from the oil and gas sector, and we asked this question: can you trust digital twins for critical decisions today? And you see the alternatives from not sure to no, I don't use digital twins for critical decisions, I use digital twins for information. Yes, but only if the digital twin is one of several sources of information and decision making must not be time constrained. Yes, I trust a digital twin as a primary source of information, but still not time constrained, or as a primary source of information, also when I'm time constrained or automated. And this is the distribution of the responses we got during that webinar. And our take on this is for the industry to really take advantage of digital investments. We would have liked to see these lower bars with the dark blue color, i.e. that you really trust your digital twin and that you can use it for critical decisions. Then you get value for money, and you then really turn your digital twin into a real asset. So what is a digital twin then? In one way, you can say that our industry have used digital twins for a long time. We just haven't called them digital twins. We make models of the reservoir, we make models of the process facility and simulate how a oil and gas process would behave. We make models of the structures, we analyze structures and so on. So this has been going on for, as you know, a very long time. But I guess what is happening now with the rapid development of digital technology, whether that is on the sensor side or it's cloud-based computing or artificial intelligence, means that we can do so much more. So we have a definition of digital twins, saying that a digital twin is a virtual representation of a system or asset that calculates system states and makes system information available through integrated models and data with the purpose of providing decision support over its life cycle. And what you will see through the presentation, that is providing decision support is an important feature in what we have developed, because we think that we see digital twins as a tool of taking better decisions during operations, but also during the engineering phase. Now, this definition is still pretty wide, so we tried to make it a bit sharper and came up with this way of describing it. When you are in the design phase, we've said that it operates in standalone, but when you take it into operations, it can either describe the asset. If you add a bit of sensor signals, the other data flows, it can provide some kind of diagnostic of the condition. Add a bit intelligence, you can start to predict future states. A bit more of intelligence, you can start to prescribe recommended actions, and even more intelligence, you can operate in an autonomous mode. And in our dialogues with our customers, we find this way of describing a digital twin quite useful, because if you go into a room with a number of people, even from the same organization, and you start to talk about digital twins, some are in descriptive mindset, while others are in an autonomous mindset, and then you are simply not getting anywhere. Even if you try a yellow sticker exercise, it won't really help. So to be precise, both within the operator perspective, but also in the dialogue between the operator and operators and the contractors or vendors, being clear, okay, what kind of digital twin am I looking at? And needless to say, the more advanced the digital twin, the higher the demands on data quality, on algorithm quality, and so on. So it's a question of finding the right balance. So how do you then quality assure a digital twin? What we came up with is splitting the digital twin and the assurance process into manageable parts. It's about the function of the digital twin. So what problem am I going to solve? What kind of question do I need to be able to answer to say, yes, I've solved that problem? What kind of input do I need? How do I want to present my results and so on? So we have, in the recommended practice, defined a process for how do you set the requirements to the function of the digital twin. Next part is the operational side. You need the digital twin to be trustworthy over time. And therefore, you have to have a process in place to ensure that the digital twin changes as your physical asset change. Because your physical asset will be subject to maintenance, to modification, maybe some degradation mechanisms. And you need to tell the user of a digital twin, that he can trust the twin at any one time. And therefore you need a process in place which could be partly automated. You can listen to the performance of sensors and data streams and see if the data quality is there over time. And you also need a time-based process in place to check that you are actually are up to date with any modifications of the asset. Then it's a question of the platform. A digital twin most likely will not have its own IT platform. It will operate on the platform from the company, or from the, in case of a software as a service solution, from the platform from the vendor or the contractor. But they then need to ensure that the digital twin actually works in line with the platform. So issues like data handling, like cybersecurity, architecture, interoperability, service level agreements, etc., are in place. If you're sort of coming back to this scale, if you have a digital twin simply just describing the asset, you can probably live with a slower response time than if you are operating in a predictive or automated mode. And that will also then drive what kind of demands you will have on your platform provider and the solutions there. Then we have wrapped around the concept of organizational maturity. We've done a number of investigations on data quality or lack of data quality. These typically start with a technical deep dive on the quality aspects and why the data signals lack in quality. But it very often ends with looking at the organization that have made this solution. So we often find that you can, and same with digital twins, a team of good programmers can make a good digital twin, a good data solution. But to have something that is sustainable, something that will work over time, you need certain capabilities in place with respect to processes, with respect to governance, with respect to training of people, and so on. And that is part of the assessment of this process. So we then provide a little bit of more detail. So it's about specifying the function of the digital twin and take that into your development process before you are ready to deploy. And with the function, it's about, okay, what problem am I going to solve? What kind of key decisions do I need to be able to make to address that need? Who are involved? What are my requirements to the user interface? What about data quality, algorithm quality? Maybe you realize that through this iteration that you don't have enough data to take that key decision that you want to take to address that need. What about requirements from outside organizations? We see a big interest in digital twins or digital solutions from the government bodies like the Petroleum Safety Authority in Norway and others, where assets will be increasingly depending on digital solutions, and maybe the framework or legislation and regulations haven't really caught up to that. So how do they exercise that? And then I mentioned the operation. So how do you follow up or a process in place to follow up changes or modifications to the asset? How that is impacting on the function of the digital twin? And also continuously monitor what can be monitored with respect to data quality, models, sensor systems, and so on. And I mentioned the platform part of it with the asset information model that needs to connect to the digital twin and the asset. How you handle IoT and sensor infrastructure, cybersecurity, and so on. And then the management processes to need to have in place to ensure that you have the right level of support for that particular digital twins application. Now, I guess needless to say, behind all of these blue boxes, there's a set of requirements and recommendations in this document that will not go through in this session. So, and then ensuring that you have an organization in place that can, over time, build and support the digital solution that you will depend on. So we think that this is sort of one aspect that will enable the industry to trust digital twins for critical decisions, which I think is needed to move on. What I've talked about today is this new recommended practice on digital twins as such. There are other DNV documents, one on data quality. So how do you ensure and quality assure the quality of data streams, which are important not only on digital twins, but other digital solutions? How do you quality assure artificial intelligence solutions? So we have a process for that as well. How do you quality assure sensor systems with the challenge that from the very sensor to where the use information, you may have passed through different hosts that may have an impact on the signals and depending on what you're going to use it for. And we also have a new recommended practice on physics-based simulation models in comparison to the data-driven. So a lot of the twins, of course, will be based on physics-based simulation, and will probably a blend of the two, a hybrid, and also need to have good quality assurance processes in place for that. Supporting that, we are working on a large joint industry project called READY, which works with trying to standardize asset information models. And in the ideal world, if you can use the same, if you like, tag structure from the vendor to the main contractor to the operator, and that will sort of have a continuous flow of consistency and information throughout the project. We think there is a lot of time to be gained. So with that, I'll stop talking and give you a brief intro on our thinking on how to make digital twins a real asset, and so that you are really able to use them for critical decisions. We think that is a way of the industry to become more sustainable and more efficient. So with that, I'll stop sharing and hand the word back to you, Roland.
Thanks, Shell. That was excellent. Can I encourage our audience to make use of the Slido questions? We have one on already, but I do have a number of questions to help us get started. So this first question, it reads, in a hull structure twin for a floating facility, e.g. an FPSO, how much detail does DMVGL expect to see in the model? As an example, reduction of a FPSO hull shell plating thickness due to corrosion is relatively easy to measure on a regular basis and to incorporate into a whole structural digital twin. However, when it comes to, for example, localized pitting, corrosion on horizontal surfaces in tanks, or fatigue cracks of bracket welds, typically at a bracket at the toe, or corrosion wastage along the bottom edge of a bulkhead, how much of detail like this, if any, does DMGL expect to be included in a structural digital twin? Okay. So a question was, how much detail do you need?
Okay, yeah, and if I then may start by taking you back to the presentation I just made. When making a digital twin, in this case, a structural digital twin, I think the first thing to do is to ask, okay, what problem am I going to solve? And if the answer is, I'm going to have a dedicated model that addresses all levels of corrosion defects, then of course there has to be a match between what you can detect and the sort of granularity and level of your model. There's no point having a very coarse finite element model and then trying to model pitting corrosion, because the model won't pick it up. So there has to be a match between the model and the problem that you are trying to solve. And the quality of the data that you will get, i.e. the pitting measurements or whatever you're looking for. As a class society, yes, we accept and encourage digital twins for maintenance planning and integrity monitoring. But what we would encourage is a close dialogue with the ones making this solution before it's presented for approval, because then we can guide a bit. So you don't sort of spend a lot of money and saying, here it is, and we say, okay, sorry guys, it's not detailed enough. So involve us in the process. It's part of our job as a class society to help guiding through this process. But of course, if you want to model pitting corrosion, has to be a match between what you measure and the detail of your model.
Thank you, Sean.
I hope that, yeah.
Sorry, carry on, I didn't mean to interrupt.
No, okay, so back to you, Roger. Roland. Yeah.
That's okay. Thank you, Charles. Does anybody on the panel like to add to the answer that Charles given? Just raise your hand or just unmute yourself if you want to add to the comments. Okay, so I'll move on to the next question. If a mooring line failed during a severe storm, would the NVGL consider, after the storm had abated, to give permission for the floating facility to continue normal operations, provided the mooring system digital twin accurately reflected the actual condition of the mooring system, and provided the operations were limited to environmental conditions during which the actual, as is a corroded or worn mooring system safety factors or usage factors for the remaining mooring lines are still within those specified by the DNVGL rules?
The very short answer is yes, but let me expand a bit. And we are assuming here that we are talking about a mooring system that can be disconnected. So in case a storm comes up again, that you can move the vessel off location. And if that's the case and there is sufficient capacity in the remaining part of the mooring system, then yes, we will accept that the vessel stays on location and continues to operate with that sea state. But again, coming back to what I first said, when making these digital twins, it's a question of, okay, what kind of problem do you need to solve? And if the problem you need to solve is the performance of your mooring system in case of a breakage, in case of a storm, of course, the digital twin have to have sufficient granularity that you can actually calculate that accurately. And also on the operational side, that you know that your model is up to date. There's no point having a brand new digital twin on a 10-year-old FPSO with a 10-year-old mooring lines. So if you then, so that means that you need a system in place, which I'm sure that we will hear more about later on the inspection side, that you actually have inspection data from your mooring lines, that you can spot any degradation, any wear and tear, corrosion, and so on your mooring system, so that your digital twin is actually up to date when you have to take that decision, and you don't take the decision on a new digital twin which haven't got these effects. So yeah, so that's how we would approach this. Again, involve us. I mean, when you're working on this kind of solution and the inspection plan and so on, I mean, yeah, talk to us before you've sort of invested all the money and have made it. And then we have, with a close dialogue with us as a class society, then we can guide you along the way. Yeah, back to
John, if you want to add to it, please carry on.
Yeah, no, I'd like to jump in here. I'm going to ask a bit of a question and make a statement as well. It's like, there's a company I've worked with recently, and what they've developed for mooring systems is a spring technology, which allows sort of a reduction in snatch loads and loads in the mooring systems. But what they've embedded within the mooring system as well is a sensor technology, which allows you to sort of understand what the loads are happening during different times. Now, based on sort of the battery requirements and the power requirements, it can either be done in sort of short bursts or over a period of time. Now, but I guess what this has given you is that extra data and live data for the mooring system itself. So I guess a question back to yourself is like, the data obviously is the most important thing for managing the accuracy of the digital twin itself. But are you seeing more technologies coming in for that real-time monitoring from mooring systems that help those sort of digital twins to build out?
Yes, we see a lot happening on the sensor side and also on the robotics side. We are, as one example, we are working with Equinor on the Krafla field development of the coast of Norway. Okay, this is a fixed installation, but nevertheless, I think it's interesting to reflect a bit about. Equinor have decided to implement this recommended practice. Krafla will be the first unmanned process facility that they have embarked on. So you're out in the North Sea, you have no helideck, you have no living quarters, but you have a facility that is supposed to operate without human intervention. A short time window in the spring and a short time window in the autumn, where you will enter the facility by boat. The rest of the time, there are no people there. There are robots crawling around doing things that otherwise human beings would do. And of course, there is a lot of sensors and digital solutions to tell you about the condition of the facility. So which means you have to basically sort of throw out some of your own knowledge and think again. So how would I look after integrity on an installation like this? How would I build for an optimum level of maintenance? And that, of course, comes with a lot of sensors. Appreciate it's not a floating thing, but nevertheless, it sort of shows you, I think, what our industry is capable of doing, and which wasn't possible some years ago. So I think we'll see much more of that. But of course, with that comes then the understanding, okay, so I have all these sensors. What kind of quality of the data is acceptable? Because we know it will not be perfect. Sensors drift. Signals will be interrupted. So what kind of demands do I put on my sensor system so I can use that to take the decisions I need to take? So in case of the mooring line that you mentioned, yes, I must have data of a sufficient quality that I can take quite sophisticated decisions on the condition of the mooring lines. So then the sensors have to be, if you like, calibrated with the kind of calculations you want to do and the kind of decisions you want to make. And I think that is an important aspect of sort of us learning new tricks or new tools going forward in this digital space.
Michelle, we've got a couple of questions on Slido, and I will come to one of them a bit later on because we've got a very similar question about the economics. But I'd like to ask a question from Kamari Sari. When digital twins become fully automated, it will require seamless communications, high volumes of data shared. What kind of communications technology do you think will be necessary and will be used? Would one of the panel like to pick that up?
Yeah, this is, I'm afraid, a bit outside of my area on exactly what kind of solution you would be looking for. So if one of my fellow panelists are good on communication technology, then I would appreciate some help. But what I can say, if you while you are thinking about a good answer, is that when digital twins becomes fully automated, they start to look very similar like control systems. And then, of course, you have to then start thinking about a digital twin like the kind of safety critical things that you have in a safety and automation system. That also require a different mindset and a different way of building the digital twin and putting demands on data and communication technology and so on. But exactly what kind of communication, I mean, if you have a fixed installation, you have obviously fiber optics to shore. And if I go back to the Equinor example on Krafla, they will have an onshore operations center, not a control room on the platform, but an onshore operations center where they will manage the platform from. Yes, so they will have redundancy, they have fiber optics for that type of communication. But out on the ocean, I'm afraid that one I have to pass on to someone else that is better on communication technology than I am.
Thank you, Shai. Anybody else on the panel would like to try and ask that question or add to the excellent answer that Shell's given us?
Again, I'm not an instrument engineer, but just a comment, if I may. Companies like Oceaneering, with their ROVs and unmanned autonomous vessels, they can pass data direct to the FPSO via communication systems, Wi-Fi and whatever. And then from an FPSO, you can transmit it straight to the beach. via satellites, typically. And you can get real-time data from the inspection work you're carrying out.
I guess to jump in there, I guess similar to everybody else, one thing we don't have on panel is a communications expert. But I think a lot of the questions aimed at here as well is also sort of bandwidth. With the amount and size of data that you can transfer, perhaps for enabling these digital twins. And the little bit I do know from working with some companies who've been involved in sort of offshore communications devices, I guess the fact that, you know, as we progress, like all things onshore, the offshore sort of bandwidth for internet is increasing all the time. And you get some platforms that are sort of reaching 4G, 5G sort of network levels, and there's a lot of communications companies that are working in those areas. I think it's the more sophisticated those systems get to allow you to increase the amount of bandwidth will allow the amount of data transfer to be made. And I guess once that really sort of starts to kick in, then I suppose it enables that whole Internet of Things aspect, and will help, you know, sort of drive the seamless communications with the volumes that are necessary for some of these broader or larger sort of digital twins. But that's my rudimentary understanding. I'm not sure if it's answering the question, but a little bit of input.
Yeah,
Thank you, John.
From our point of view, from Fugro, we see that same problem popping up with our autonomous and remote operations. It's mostly bandwidth and how much data do we need, and do we need to send to shore? At the moment, that's mostly satellite technology. And what you see is very large steps in the technology itself. I'm not a communications expert, so I don't know the details, but I see them progressing, and I see that the capabilities that we are able to provide on our remote operations and our autonomous operations are increasing. And the same goes for our crewed vessels, which do have a digital twin, is that because of the increased bandwidth, we are now capable of using them live on board of a vessel anywhere in the world.
Thank you, John. The next question is actually for you. One of the challenges stated by a major oil and gas operating entity is the integration of digital tools, in particular to larger organizations that have been around for many years. The fear is really the unknown and is seen more of a threat than complementing our current ways of working. How do we as an industry address such concerns in a collaborative manner with the evolution of these new technologies?
Yeah, great question. I suppose it comes into trust, transparency, and integrity in some respects, right? So, a number of years ago, when I worked with Wood, so Wood Group were developing these sort of digital tools, and I remember, you know, for subsea systems, we were looking at using basically analytics to look at everything from subsea control systems and their behavior and aspects, and particularly things that were out with sort of warranties for OEMs and how you could help, you know, sort of sustain and identify sort of errors within systems, and identify like we talked about before, some of those preventative and predictive aspects. And what I found interesting was the fact that sometimes we go to operators and we sort of say, here's what we can do, here's where we've saved money based on costs in the past for people, and we want to try and see if we can do the same for yourself. And the barriers that came up time and time again were kind of twofold. First of all, it was about the data and the management and control of the data. So even though, you know, some operators could have sensors on huge amounts of subsea equipment, gathering, you know, terabytes of data that was never really utilized, they were, you know, sort of naturally in fear of just handing over or gifting data in some respects, and that's understandable from a human perspective. And the other sort of barrier, in some respects, really was the fear of the unknown. You know, so like you kind of mentioned that if you've got a system that's working, you know, you don't want to be told that something needs to be done to it because it's performing as it should be. So you're sort of generating these additional costs in order to create something that in essence isn't seen as a problem. Now, this is where I think the digital factor and the human factors often combine. And the reality is, if you're unemotional about it and you're looking at the data and you're identifying where the problems are, then you have to be unemotional with what the realities or the risks are. And I think that's, sort of operators of equipment are getting more, sort of, I guess, engaged and understanding of the benefits of the data and the use of the data. And also, where you have instances happen on an increasing, sort of occurrence, then you realize that the opportunity is to use the data in order to create the opportunities to minimize any downtime in the future. And but it's kind of at the time, it can be a brave first step when you're speaking with the operators who really want to engage these areas, because what they want to do is they want to use the data, but they don't want to be told that there's a bad news story coming. They're much more comfortable with the idea of being told that everything's going to be fine. So a lot of the time with sort of engagement, it's not about sort of identifying where the risks are or where the opportunities are. And for companies, I think it's about changing the conversation to ensure that what you're getting for the work that you're putting in is greater sustainability and greater cost savings over the duration and field life of the asset, as opposed to the short-term aspect of a short-term pain with costs or requirements for sort of augmentation or changes in the subsea system, for example. And so that becomes one of the major barriers. The second thing that's one aspect. One of the other instances I came across before, speaking with a company who provide digital technology and predictive and preventive maintenance for marine systems, so ships. And so again, sensor technology to identify, so the behavior and the operation of the marine propulsion systems. And one of the first issues that they hit with speaking with the marine operators was the fact that, well, is it going to take away a number of jobs? Is it reducing down the headcount in order to digitize things? And again, it becomes that fear element. And what they had to work on to start off with was basically, no, it's an aid in order to ensure that you're understanding the behavior of your system. And what they found was, once they're embedding and adopting the technology and using the AI and machine learning in order to understand the behaviors and the benefits of the data and the algorithms, then it was an aid to them. It was minimizing the amount of work, or was allowing them to plan their work in a better, more logical way digitally, and help them do their job better. So again, there's a little bit of that winning hearts and minds, And then the very last one of them, before I open up the panel, because I'd be interested to hear the rest of the panel discussion here, is another company I spoke to, and they were looking at, they had photogrammetry for pipeline inspection. So basically kilometers and kilometers of pipelines. And effectively what they do is they take, hundreds of thousands of photographs along the full length of the pipeline. And from that, they're again using AI and machine learning in order to identify ovalities within the pipeline, any notches or dents within the pipeline itself. They're able to do point cloud, data point sort of surveys. So basically, what you're just getting was the data. You can have the pictures as well, but what they're identifying was locations where you would go back to identify spans in the pipeline in case it had any additional loads, in case there's any ovality which could cause sort of detriment to the pipeline itself. So effectively, you ran the pipeline. The machine learning and the AI pumped out the I guess the hit points, the hot points to go back to and check on, and then eliminated all the other parts that were good, and you got effectively a data file. And So this guy was effectively, he was an analyst and a photographer, by and large. And he mentioned he was speaking to this major oil and gas operator and speaking to the inspection guy. And I said, there's your data and there's your points. And the guy said to him, but where's the pipeline? I said, well, you don't need the pipeline. We've taken all the data, we've analyzed everything, and we've told you exactly where it is. And here's your sort of data cloud. But this guy spent 20 years looking at pipelines from ROV footage. And I guess from Oceaneering, you probably appreciate this aspect as well. The inspector, what he wanted to see was a pipeline. And this analyst was saying, well, you don't need to see the pipeline anymore. It says you have all the data there. But his point was, and when he was telling me, I was explaining, you've got an inspector who spent 20 years perhaps of his career looking at pipelines and seeing where the anomalies are. To have that taken away from you and said, don't worry, you don't need to look at a pipeline anymore, we'll do all that for you, is alien. So it's a bit about, again, winning those hearts and minds and sort of recognizing that you can have the photographs, you can have the full pipeline, which beautiful graphics you can get, but also, you just need the data. And so a lot of this is about winning hearts and mind, understanding people's perspective, and that's human behaviors with digitalization and with data itself, and how to be able to manage that. So that's a very long-winded answer to that question. So I hope that was all right for you, Rolly. But anybody else, it'd be great to hear your thoughts as well.
Would any other panel like to add anything to the excellent answer John's given us?
Thank you, John. That was a very excellent reply. But I'd just like to add a little bit to the operations side. As you said, the operations people, if they have a system that works, there's always this inertia towards changing it. It's just normal human behavior. And then if you come with new technology, there's always an aversion towards it. People are scared that they become obsolete, that they lose their jobs. And it's a question of education and training, really, managing the human behavior. For them to understand the benefits of it. In most cases, it's not a question about them losing their jobs. It's just combining their experience with modern technology and driving the change for improved safety and improved economics and so on. And allowing them to better plan their offshore work. For instance, we're talking here about the mooring line failure. If we have the data and the tools and the systems to predict how long that mooring line is going to last, then they can plan the replacement. To order a new mooring line, delivery times are often very long, if there's a problem. But with these new tools, they can actually predict when that mooring line comes to the end of its lifespan, and they can put order in for equipment and materials and for marine ops vessels in good time before that. And they can often get much better prices for everything because they order it not in a panic last minute when the vendors and contractors realize that the client is up against the wall. They can do it at their leisure when the market conditions are good. But it all comes down to education.
Totally agree. I think, in some respects, I think for sort of major equipment operators or oil and gas operators, whoever it may be, there has to be a top-down and an all the way down approach. Because a lot of the times what will happen is you'll speak to project managers or operations managers, and they'll have their own budgets, but they're not incentivized to identify digital solutions that can help enable or unlock sort of value, then they're not going to engage with it. And also, so that element of not being afraid that, like you say, it's better to plan for failure and be prepared for it rather than have failure occur with the safety implications and the cost implications associated with that. And having that embedded within an organization, I think is the way to be able to ensure digitalization is rolled out more easily.
Thank you, John.
I'll add to that also. I think it's a really important part for the education and winning the hearts and the minds of the people paying for these services to convince them. For example, at Oceaneering, we've been offering these remote technologies since 2018. And why would you not want to send people offshore anymore. I mean, there's an option to not send people offshore. And really, there's been no early adopters to this technology or this approach. And what it really took to kind of sink in was COVID. You physically cannot send people offshore anymore. And then like a light switch went off. Like, oh, well, why have we been doing this forever? And it's just been, really the forced scenario of remote and digital solutions. Now it's popular. It's been interesting.
If I may add to that, Mitch, we see the same thing when it's sort of coming up equipment where in the past people have traveled around the globe on airplanes to watch tests and do things that you actually could do remotely. So now we do a lot of surveys with cameras and basically report that into a central place rather than sending people around the globe. Not a sort of more, if you like, traditional technology, but used in a different way. And I doubt that would have happened without COVID. But the beauty, of course, is that when you don't have people out, but have them sort of your experts in one location, you can offer so much more advice because you can pull people in and reflect on the results if you see some anomalies, rather than having that poor guy by himself or girl having to take the decision. So I think a benefit when you really adopt digital technologies is that you have doing what we are doing now, gather 6 experts from around the world without having to travel to the location. This webinar probably wouldn't have happened if we had to travel to one location, all of us. And now we can be at this webinar parts of the day, and we can meet other clients and do other things the rest of the day. So I think this COVID have accelerated the uptake of digital.
Thank you, Joe.
Yeah, I think I see the same. For us, COVID has been a catalyst, and what we see all across the board, whether it's client acceptance or the technical vessel manager that cannot go on board for set trials or maintenance, all have gone remote via digital twin solutions. And the crisis being there, the vessels being globally around the world, the problems are solved via this digital twin solution. And I think the crisis itself has enabled the technology to be adapted by critical people inside the company, but also outside the company.
Thank you. Mitch, would you like to just sort of carry on expanding on what the benefits are of using remote inspections? I mean, you started to allude to that. Is there anything you'd like to add in terms of the benefits you see?
Yeah, sure. I think pretty basically there's, the savings of money and time, and then there's an increased benefit of increased safety. So for time, scheduling is becoming really difficult these days with operations picking up. You have weather you're always dealing with, quarantine restrictions, and SIMOPS. So you sometimes only have small windows of time to go and kind of cherry pick when you can do inspections subsea with the ROVs. And these windows are becoming smaller and smaller with drilling operations taking priority offshore. So, with technology and bandwidth becoming more available, these scheduling challenges can be mitigated with just a flip of a switch. So you can just turn up the bandwidth and turn on the remote viewing at your convenience. And toggling between this operation mode and inspection mode has really saved time for completing inspections. And as we all know, time is money. But money also, from a sense, is having these, not having people travel offshore, spending time on a day rate traveling offshore, not spending money on plane tickets, not spending money on having someone in a hotel room in quarantine for a couple of weeks, really all saves money. And then not having someone offshore, opposed to having someone sitting in their living room completing these inspections remotely, you can sometimes charge a lower day rate and saving money. So you're really all around the board, really reducing costs. And then from safety standpoint, inherently, if you're not sending people offshore, you are increasing safety. So you're not having people traveling, not having people offshore, really increasing safety from that point of view. And then as a bonus, we alluded to earlier, but as a bonus, you can increase your operational excellence by having your subject matter experts centrally managed and conducting these inspections from a centrally managed location. So you can have your best people working around the world simultaneously at the same time. So it's really time, money, safety, and operational excellence is all increased with these remote technologies.
I think Mitch shot in there as well. It's like one of the things I've noticed, like a number of years back when we used to talk about, some high-speed pipeline inspections, you're reducing down the number of days of a vessel, and that inspection vessel costs X $100,000 a day, and you see what you're saving. And I think now in the environment in the world that we're in now, what people are able to sort of say is you're able to offset the carbon that you're emitting as well. And that goes down to every level of what we're doing. If it's the number of vessels days, then it's the carbon associated with that. If it's the number of people traveling, then it's a carbon emissions associated with that. So I think what you're going to find as well in this ESG world, which is correct and right, and a drive for decarbonisation, that you're going to see a lot of operators as well wanting to identify and herald where they're saving, as well as cost and time, but also reducing emissions based on the operations of their assets.
Yeah, good point.
Thank you for that answer. I'd like to stay on a theme that's both in the questions I've got and coming up on the screen about economics and value. We have a Slido question from Ravi Prakash, which says mixed reality has a great potential in making the development quick and accessing the risk good. Affordability, however, is one of the biggest questions. How can that be tackled? And I'd like to marry that to one of the questions I've got in front of me, which is really for Shell to answer. I'd like, is getting value from your investments in digital twins can be hard. What is DNV's best advice for getting it right? So there's sort of slightly two aspects of the economics and cost, benefit and value there. Could you answer those, Shell?
There we are, unmuted. Yes, I'll give it a try. So I think that to really get value from your digital investments is being clear on what exactly are you after. Don't get sort of I have all this data, what can I do now? Which some digital initiatives start with. They normally take off on an expensive tangent. Or if as an operator, you sort of don't really sure, but start some kind of initiative. So being very clear and precise, what is that you are looking for? What kind of data quality do I need for that particular application? And coming back to this sort of the staircase I showed, it's a huge difference between something that's just be there to describe an asset to something that is adding autonomous functions on top. So being very clear on that is a good way of also getting money for your investments. And well, perhaps not saving money, but sort of coming back to what has been mentioned by John and Mitch, and Kai as well, and the importance of changing the way you work. There is little value in investing in a sophisticated digital solution if you are not able to change the way you work, which is getting the minds of the people on board, which is sort of taking advantage of AI solution that may scan vast amount of data much faster than a human being coming to, I think the example mentioned here by the inspector who was used at looking at pipelines. There is no point having a sophisticated tool if you can't work with this guy, and preferably involve him in the development, not just landing a new solution on his desk and say, here we are, but involving the user in the process so that you get the buy-in, but also get the experience, and then really change the way you work. As we talked about in the sort of last session here, you don't have to travel that much anymore, because you can get access to experts through digital technology anywhere around the globe. So I think that would be some things needed that you have to consider to really get value from your digital investments. When it comes to the tools, I think augmented reality was mentioned. I think what we will see, like any other digital technology, prices will just drop and drop. So although some of these devices are costly today, think about what we have on our mobile phones today versus what we had a couple of years ago. It's sort of I think we'll see that cost compression and that level of advancement also on the digital tool side. But I still think that the biggest cost opportunity is changing the way you work and really embrace these tools. Less number of air tickets, less number of standby days for people not getting offshore and so on. I think is far more costly than the tools we need.
So basically, affordability will be driven by market forces, take up of digital twins, and more people coming in the market to supply it. So that will make it more affordable in the long term.
Yes.
Yeah. Thank you for that, Shell. I'd like to dip out and go to a Slido question on governance, which is from Matt Bolton of the Naval Engineering SIG. He says, do you foresee a future where digital twins under certain circumstances might become a necessity to demonstrate compliance with regulatory requirements? And I'll open that up to all of the panel, but anybody like to start? So the question was, do you foresee a future where digital twins under certain circumstances might become a necessity to demonstrate compliance with regulatory requirements?
If I may start, or Peter, you want to go first?
Yeah, sure. And I do foresee a future, and specifically in crisis situations like COVID or any other natural disaster, for example, where it could become one. And I also do see that the possibility of class societies changing the way they work, thus needing it to become a requirement.
If I may add something to that, please. Also, as the number of people working on facilities offshore are reduced steadily as technology advances and eventually moving towards unmanned facilities, I believe there should be a need for regulations to reflect this requirement. We don't have people anymore offshore in the numbers as before, and digital twins and their acceptance and the way they are regulated will become a regulatory requirement. So you see the fact that we have digital twins becoming driving the legislation, or do you see the legislation seeing the benefits of digital twins actually then encompassing? I mean, what's going to be the driver behind it? The efficacy of digital twins, or just another way of improving regulation?
Well, in principle, it's a tool, and it's a tool to be able to downman operations offshore and monitor better. So I think as a tool, there are multiple tools that regulations use to be able to do the work, and this is one of them. Yeah, and we already see DNV coming up with their recommended practice A204. That's a first step towards regulation. I mean, it is currently the best roadmap for digital twins and digitalization, and certainly classification societies will build on that, on those requirements.
Yes, and if I sort of may add to that, I mean, the kind of take our job as a ship classification society. There are about 12,000 vessels worldwide with DNV class, and we now collect a lot of data from the ships. A lot of things we can do today without sending a guy in a boiler suit on board the vessel. I mean, why should we? We can then listen to the condition of the ship for a number of aspects. Then, okay, certain things you need to check physically, but you can see patterns that otherwise we were not possible to see. You can see early signs of degradation that you can sort of share across a fleet and so on. So I think this digitalization will drive efficiency, it will drive a new way of working, and it will demand a different legislation and a different way of following things up from regulators, from government bodies. So I think that's also something that will happen in our industry. And when look at the sort of society around us and how legislation is changing on the banking side, how our personal integrity is safeguarded with the GDPR legislation and so on. That wasn't necessary 15, 20 years ago when we got everything by normal mail. But of course now when we are leaving a lot of information behind every time we go online, yeah, new legislation is needed, a new approach from the authorities and regulators are needed, and I think that we will see that in our industry as well.
Thank you, Kjell. I'd like to move on now to a question which is basically really about change. It says, and this is for you, Kjell, we all know that physical assets will change over time due to degradation and modification, etc. How do you keep your digital twin up to date and at any time in an assured manner? E.g., does the guidance A204 quality assured process stipulate a frequency for periodic audits?
Okay, it doesn't sort of specify a periodic frequency, but it points out that a process should be in place for doing periodic surveys and updates to ensure that your twin reflects the actual condition. It also talks about one thing is the periodic surveys, the other is what you can do automatically. A lot of integrity information or sensor data and health of sensors can be monitored automatically. So you don't need to inspect the sensors, you simply listen to the sensors and look for drift and look for outliers, and that is a way of securing health, and then you have to make that information available to the user. I don't know, Mitch, maybe you want to say something about sort of how you monitor the health of ROVs and other equipment that you have. I'm sure you do this on a regular basis.
Monitor the health and operational status of the ROVs.
Yes, as a means of increasing the trustworthiness of the results that they send back.
Yeah, well, we have the ROVs have operational teams on board that are there monitoring them, and so we have kind of boots on the ground doing that role. We don't have a way of remotely monitoring the health of the ROVs. It's all if the ROV is broken, we will know it immediately.
Right, but is there a way of knowing if the ROV start sending signals that you feel that this can't be right?
Yes.
So how do you sort of track that, sort of the trustworthiness of the information that comes out from the ROV?
Right. It all comes down to the bandwidth. I mean, the minute we start seeing a lag, I'm monitoring a video right now. Actually, I'm doing a remote inspection as we speak during this presentation right now, and I'm seeing about 45 seconds delay. So it should be closer to like 20 seconds delay. So it just comes on a bandwidth.
Right.
We have to just do some adjustments. So it just comes on to the delay of information flowing to you.
Thanks, Mitch. I'd like to dip out into Slido again for a slightly off-field question. The question is anonymous. It says, how do you see the role of metocean data, i.e. waves, currents and winds, etc., being used in the digital twins you are talking about?
I'll jump in here, Rory, because I saw that question actually. I guess the immediate answer is we're seeing it at the moment, and we do see it. So again, going back on some of my previous roles and companies that I worked with, when I worked with one group, they acquired a business called MCS. MCS did a lot of riser and mooring analysis, and they developed a software called Optima for drilling risers. And what that allowed you to do is it was an onboard system that went onto drilling platforms. And what it gave them was an operational window for drilling. And it gave you live analysis of the mid-ocean data in the area. So generally, like, you know, your drilling rigs will have operation parameters where, as we say, if you get up to a certain sea state, winds, whatever, that they disconnect for safety reasons and then, you know, so reconnect it when it's safe to do so. But what the Optima software allowed you to do was use that real-time data to use the waves, wind, current, and analyze the fatigue and load on the drill string. So once you're within the operational limits of the drill string, there was no need to disconnect. So what that allowed you to do was increase your operational window for your drilling and removed the conservative element for having to disconnect for safety reasons. It was analyzed, it was understood, and it was used. So that's to be fair, like, you know, Optima has been around for quite a number of years. So in some respects, you know, we have these digital technologies that have been there for a while, but what they're used in is in almost bespoke sort of scenarios. So if you expand that out, we sort of think, okay, there's a very high payback for increasing the amount of time that you can remain drilling for the cost associated with drill rigs. But similarly, if you were able to deploy that on an FPSO or in other environments where you're basically continuing monitoring the systems, then it can be deployed and it can be used. Now, I suppose it becomes an aspect of like, what's the payback? You know, what's the benefit? And you're getting to your sort of your long-term, I guess, integrity and your use then. And I think these are the things that are becoming less bespoke now and being more used widespread. But I think it's important thing for people to realize that the technology isn't new in some respects, and it is cutting edge, but it feels a lot more newer because it's not there's no widespread adoption for multiple different reasons. But also the moral almost in there is not to be afraid of it because it's not as new perhaps as you think, you know. But again, I'll be interested in other people's thoughts on this.
Well, yeah, we see the same. We do the same. We have a service for the mid-ocean data, and which we are also using to connect to other types of data to be able to predict hull fouling from an efficiency point of view and determine when are we cleaning our ships, when it is economical, and such goals will need to be determined by the operator to be able to assess if weather data is practical to use. It is available, and I think importantly, you need to connect the dots with the other types of data to create a certain data set that you can interpret.
Yeah, no, I totally agree. It's almost like you're creating a data ecosystem, and
Yes.
and it's getting that interconnection that really gives the value as well. So totally agree, Peter.
And there are a lot of data systems out there generating weather data, and any sort of type of data, engine data, vibration data, etc. And at some stage, and at the moment we are there with AI, etc. We're able to process that large amounts of data to be able to assess what is the current status of a certain type of equipment, whether it's a complete boat or it's a pump.
And I guess we've seen other systems as well, where in again marine shipping applications, they've used, I guess, you know, sort of weather data and to a certain extent mid-ocean data to help predict the most economic sort of route for shipping. You know, so
Yes.
basically, effectively avoiding the storms, so you're not going to get you're not going to have, you know, lack of utilization based on your propulsion systems. You know, so
Exactly that. Yeah, so it's weather, but also current data to optimize routes. And what we see happening is that people just sail the shortest route while going full ahead into 3 knots of current. If you go 2 miles out, you're free, or 50 miles out, you're free, and you're there 1 day earlier, which again comes to cost. And that's
and counterintuitive
itself,
to start off with,
yeah.
but it's perfect, yeah.
Yeah, and in itself, it doesn't get used because they don't see the value. A captain can think of his own route. But if you start connected it to cost, operational cost, fuel cost, CO2 emissions, then people will start to notice.
No, I totally agree. And again, it's one of those sort of things, again, like you said, Peter, yourself, and like what Lobs has said, it's kind of like, sometimes we think about digitalization as being this future focused thing. It's like, actually, the future is now. A lot of this equipment, this data, this technology is already here. It's about adoption. So I guess that's probably one of the major takeaways we can get from this panel session, is the fact that people understand that it's about seeking out what digital technology you need and adopting it.
Yeah, and it's not. I think what people also need to realize, you don't need to start with the 3D model of the complete North Sea. There are already data sets that if you connect them, that's called a digital twin. And you can start small with a certain goal in mind and expand from there. Whether that's met ocean data or maintenance data.
Well, fully support you, Peter. I mean, there's no need to start with a sort of a fully covering digital twin of absolutely everything. Then you will never get off the ground. So start small, learn from that, be clear on, okay, what problem am I going to solve now? And the solution may be there, and then sort of start using it, start to see how can I become more efficient, release less emissions and so on from that application, and then take on the next one. So I think it's a never-ending journey.
Well, it will definitely spread out from the first, of course, if it's positive, but from the first small project that you're doing and changing of work, it will spread out because you will see opportunities arise next to the topic that you are doing.
If I just may add a little bit on a higher level, digitalization and digital twins, they should be driven by business needs. It's not an IT project. It's what does your company need from a business point of view to enhance the performance for their business. And because of that, the digitalization, digital twins, they must be correctly specified to support the business needs.
And I also think, and what we've seen a number of examples, when you get this right, and when you then sort of mobilize your organization and get creativity going, sort of coming back to your example, John, about the pipeline inspector, when you have won him on board and he starts to think, well, I could actually do things differently, and I have this idea, and I have that idea, and suddenly you sort of get this sort of flows of ideas going and saying, yes, we'll do it this and we do that. Then I think this really becomes powerful. And I think that's one of the recipes for the successful organizations. They basically, yes, it starts from the top and you maybe have to sort of drive it. But when you get the sort of thinking and realization of what these tools can actually do for me, what kind of quite mundane and boring tasks that can be removed because I have all the information at hand. I can apply my brains, my skills on really solving a problem, not searching for information, for example. So there is then it gets powerful.
Thank you for that, guys. I'd like just to move on a bit now, and some of the next two questions I think partly have been asked. These are really for you, Peter. So I'm going to combine two questions. First part is, any particular advice on views on what is required from an organizational perspective to build and operate digital twins successfully? And what extra equipment or software, i.e. is required to transition from the traditional methods of work to remote digital twin applications and streaming? They're sort of slightly, so Peter, can you have a go at that, please?
Yeah, sure. Well, first of all, I think you need a high-level standard bearer within the company to be able to drive it. Acceptance in the complete authority chain, whether that's a client, a CEO, but from top to bottom. And again, coming back to the previous answer and question, starting small will really increase the acceptance of the operator, seeing the possibility and the different type of work that he needs to do. And that will increase the complexity of a digital twin and thus also the equipment that you would need. Mostly, I think it's communication and communication protocols. Sensors, of course, well, it helps. Asset scans, 3D scans, point clouds, 3D goggles, and then the proper interpretation. So the learning how to work with the data. It's not per se an equipment, but I think it's crucial. There's multiple companies that are able to write perfect software to be able to show data, but if you cannot interpret it, I think that's really important. And the equipment that you need really depends on what you're going to do. So what we are now looking at, for example, is remote technical survey of our assets. We need a 3D point cloud and augmented reality goggles and good internet. It always comes back to that.
Would anybody like to add to that from the panel? Okay, I'd like to move on to some questions about skill. I've got one on the Slido, but I'll start with the one I've got in front of me. And again, this is for you, Tar. So I'll read both questions, and perhaps there's a certain amount of overlap. So this is for Kai. Do you believe that the human-machine interface is unprepared for the introduction of these digital twins, automated and remote monitoring tools? And how big is the IT skills gap and the need for more training across the industry, including considering the ability to transfer oil and gas personnel into green energy jobs or supporting the blue economy across this energy transition period? And we have a sort of a question on Slido which has an element of that theme in it. It's from B. Dakal. It says, how do you think we can mitigate the gap between traditional engineering approach to the skill challenge required by the digitalisation? Do you think you could answer those for us, please, Kai?
I'll try. Some of this has already been answered to some extent, but if you go back to this educational training, I think it's essential that the industry does training in this area, all aspects of it. Oil and gas industry, as an example, operations and maintenance personnel need to overcome their aversion or fear of digitalization. And this can be achieved through training. Digitalization technology will assist the industry to move forward in areas such like safety, reliability, efficiency, and better economics. And trained personnel are needed for this. It's absolutely essential in my view. And training will also assist with minimizing risks of losing highly experienced engineers and technicians. We have a good pool of engineers and technicians in the oil and gas industry at the moment working offshore with tremendous practical experience. And it's, in my view, essential that we train them so they can understand the digitalization and digital twins and can use those and can benefit from those new technologies. And also, if we don't do this, then there's a risk that we lose these people completely from the industry. They have to become familiar with these emerging technologies. Again, then transfer into the new blue economy, green economy If you are looking especially at like floating wind farms, oil and gas industry personnel have a lot of experience currently in floating technology, both engineers and operators. Mooring systems, hull design, hull analysis, topsides facilities. If you're talking about converting electricity into hydrogen and pumping it to the beach, there's a lot of know-how that exists in the oil and gas industry, which can be directly transferred over to green energy technology, but it needs training. It needs training in all areas.
If I may add to that, I think it's important to point out the common topics in whether it's a digital twin or it's floating wind energy compared to oil and gas. It's where do they connect, and it's part of the interpretation of how the data, whether a visual feed or actual through the eyes, is interpreted. And I think that's the change that needs to be made aware to the people that need to do the work. If you look at the physical rudder wheel compared to the digital rudder wheel, I'm not old enough to have made the change, but it's the same principle. I don't feel what the vessel does with this digital one or with the joystick, but now it's commonly accepted. It's the same change, but probably in a shorter time frame.
I think to add to that as well, I think it's interesting. I think one of the things we've talked about most often, or quite often in this session, is about education. And like we're saying, I think there's two aspects of it. First of all, is the existing workforce who've got this huge and tremendous sort of experience that needs to sort of translate that digital arena in order to be able to give them the time to do what they do best. B, allows them to impact and influence the digital strategies, the types of digitalization that's required. And that's but they hold on to that experience in the workforce that's there and utilizing it during this period. And then the opposite side of it is basically about the new sort of entrance into the energy industry. And I think in some respects, this is at least equally important, because, we've got to remember that, sort of technical and digital technologies are competing, so whether it be onshore or offshore, and the oil and gas industry and less so other sort of renewable energy industries are competing a lot more for a smaller, sort of skill set and graduate level technologies, students that are coming through. And we need to basically make sure that graduates and students recognize the potential in the energy industry, whether it's oil and gas, whether it's renewables, floating wind, solar, wave, whatever, and they understand the benefits of the upstream or the offshore, the marine environment for digitalization. Because as much as preserving the existing workforce, we have to ensure that we get that continuation of fresh minds and fresh thinking in from the universities and colleges and apprenticeships as well.
I think further too, you say like preserving the workforce, even though we're transferring some of the jobs onshore, that workforce and that, knowledge can't go away. You still need people reviewing that streaming data. Right, we have a video streaming right now, as I mentioned, and I still need people in the office or at home reviewing that data and managing that data and making sure the inspection is going as if they were offshore. So those jobs are just transferring to onshore. They're not going away by any means. They're transferring to another location.
Yeah, and if I may add to that also, that I think for the newer workforce, the operational experience is if you start out as a digital warrior, as it were, you start missing the real operational experience. And personally, I would prefer to see a more hybrid approach instead of all unmanning, all offshore in the medium future. that it becomes a sort of a rotating a job that to also work offshore, to also learn those skills, and then to be able to better interpret the data that you get onshore.
Thank you for that. I'm just mindful of the fact we're getting close to when we have to hand back to IMarEST Central. We've got about 2 minutes left. So I'd like you to do one final question from Slido, which is a bit overarching, but an interesting one. So what's would the panel consider are the success factors related to digital twins in terms of decarbonisation for zero emission realisation? What role do you see digital twins playing? So it's a very high level question. Does the panel have a view on this?
If I may start, I think one thing that have been mentioned, I think both by Peter and Mitch, is obviously less travel. So basically, rather than traveling to a site, you would, through digital technology and digital twins, be able to assess the condition or solve a problem from your base location. I think that is sort of one. So basically, less air traffic, and so on. That is one obvious way of doing it, I think, or benefit. Another reason is that by being able to connect data from different sources, you will, through artificial intelligence, be able to see patterns that you otherwise wouldn't have seen. So you can run your equipment much more energy efficiently. Routing of vessels, I think, was mentioned by one of you. Optimum time interval for cleaning vessels, sort of what I think Peter mentioned. So the sort of, you get access to information, you see patterns that will enable you to operate things more efficiently. That would certainly improve the impact we have on climate and CO2 emissions.
Yep, no, I agree with that. I think it's efficiency and accuracy. That's the ability that that data-enabled digital twins can give you, and that will create its own cost savings. And sometimes the trick will be identifying what those cost savings are, because the problem is when you save 20 vessel days, we've never used them to save them. They just never existed. So sometimes what you're trying to articulate is how much you've changed or saved based on what you would have done without, say, that digitalization or that digital twin.
I think we must draw to a close there as we've come to the end of our time. On behalf of the IMarEST and myself, and also our audience, I'd like to thank the panel of Kai, Chal, John, Peter and Mitch for a very, very interesting panel discussion. I think it's there's a lot more to come out of this, and thank you for your candidness and your detailed answers. And I'd like now to pass back to Shez just to close the webinar. Thank you, guys. Thank you very much.